Hi everyone, this is Algebra 2, Lesson 1-3, and we're going to be talking a lot about slope and graphing lines within this chapter, or should I say section. Before we jump into things, some things I want you to know is that we need to recall that slope equals rise over run. So rise can be up or down, and run is left or right. Something we also need to know too is the slope-intercept formula, and that is y equals m x plus b. M is our slope, and b is our y-intercept. And this is something that you have to hopefully memorize, and it would make things a lot easier. So with those notes there, let's start attaching and assimilating this knowledge that we were just given to examples here. Number one, finding slope given the graph of a line on a grid. So here we have our x-axis, here we have our y, and we need to find the slope of the line graph below. So again, slope equals rise over run. So m is my slope. M equals, let's do our rise. We're going up 1, 2, 3. That's my rise. And then over 1, 2. Now notice when I go up 1, 2, 3, I'm going up in a positive direction. So let me erase that real quick. I'm going up in a positive direction along the y-axis, right? 1, 2, 3. Notice that the numbers are going up in a positive direction, hence why I have a positive 3. And then I'm going right in a positive direction along the x-axis, and I get over 2, right? 1, 2 to hit that point. So my slope is m equals 3 over 2. Try the one on the right-hand side. Finding slope given 2 points on the line. So before, at the beginning of this lesson, we just said that m equals my slope, and I said that it was rise over run. What rise over run is y2 minus y1, x2 minus x1. So all that is all meaning the same thing. So when I see this, that I'm given 2 points, from these 2 points, I'm able to find my slope. And so what we want to do is we're going to label this negative 4x1. The 7 is going to be my y1. This is going to be my x2 and y2. You do not want to mess this part up, because when I plug these numbers into my slope formula, there's a possibility it's going to be wrong. So we have m equals, my y2 is negative 8 minus, what's my y1 is 7, over my x2, which is 2, minus negative 4, equals. Some tricks here to solve this. If you're confused how you do minus and negative 8 minus 7, you can always change the sign and make that a negative. So now you get negative 15. 2 minus negative 4, you just can change these to pluses. So I don't know if you guys knew that trick. So negative 8 plus negative 7 is negative 15. 2 minus negative 4 is the same thing as saying 2 plus 4, so that's 6. We want to simplify this fraction, and a number that goes into both 15 and 6, or the greatest number that goes into 15 and 6 is 3. Let's divide by 3. 15 divided by 3, or negative 15 divided by 3 is negative 5. 6 divided by 3 is 2. So my slope is negative 5 over 2. Try this one on the right-hand side. Number 3, finding the slope of horizontal and vertical lines. Okay, so we're going to use the same thing. We're going to use the y2 minus y1 over x2 minus x1, and that gives us our slope. I'm given 2 points. So the first thing we want to do, how are we going to label these? Let's look back at the top. x1, y1, x2, y2. And all we need to do is plug those in now. My y2 is negative 9 minus 8. x2 is 9 minus 9. Notice something happens here. Negative 9 minus negative 8, negative 17 over 0. Negative 17 over 0. When you have this happen, our slope is what is called undefined. And that would be your answer, undefined. What this looks like on a graph, if we were to graph this, I have my y and my x axes. I'm saying that my slope is undefined, and what that would come out to be, if we had the point here, let me do it in red. If we had the point here, my slope would be vertical. Vertical. So whenever you see this, say we didn't have the 2 points, just say that we were given the graph. Then if you just saw that vertical line, you know your slope is what's called undefined. Or if you're given 2 points and your denominator is 0, your slope is still undefined. Now I'm going to do the one on the right-hand side with you. You want to again label your points, x1, y1, x2, y2. So you get negative 6, y2, negative 6, minus negative 6. I'll put that in brackets so we don't get confused. And then my x2 is 6 minus, and then negative 5. 6 minus negative 6 is 0. 6 minus a negative 5 is 11. And that just comes out to being 0. So my slope is 0. So if we were to draw this, just so you can visualize it. Oop, that's not the x-axis. This is y, this is x. If we were to draw this, and say this was down here, that's what a slope of 0 looks like. It's just a flat plane. So you'd have 0 slope. And this is going to happen. This is going to arise in problems. So you want to make sure that you've at least seen them and you know how to answer when your slope is vertical, it is undefined. When it is flat and it's just straight line, it's a 0 slope, no slope. Let's move on to our next example of number 4. Finding the slope and y-intercept of a line given its equation in the form ax plus by equals c. Before we saw slope-intercept form, which is y equals mx plus b, this is what's called standard form. Standard form. From the standard form, we can move our information and convert it into slope-intercept form so that we're able to find the slope and y-intercept. So again, notice this is negative 12x plus 4y equals negative 8. So it's an ax plus by equals c form, which is called standard form. How can we get this to look like slope-intercept form, which is y equals mx plus b? How we do that? Well, we want to get it to look like that. Notice my x is on the left-hand side of the equation, but on my formula there, my x is on the right-hand side of the equation. So let's just add x here to 12x plus 12x. I'm left with 4y equals, and I'm going to put my 12x here, minus 8. I want to get y by itself, so if I divide by 4, I need to divide everything on the right-hand side by 4. So now I'm just left with y equals 12 divided by 4 is 3, and I'm left with my x. Negative 8 divided by 4 is negative 2. Now I'm left with my y equals my mx, and now it's minus b, but that's fine. Minus b, same thing. Except my b is just a negative number here. So it's still plus b form. Okay, so it asked us to find our slope. My slope is m, the letter m. Remember, that's saying m times x. So the m is technically by itself. So my slope of m equals 3, or 3 over 1, same thing. And then my y-intercept is my b, which equals negative 2. So just the 3 is my slope, and the negative 2 is my y-intercept. Again, the x is not attached to that 3. It's saying 3 times x, the slope times x. And go ahead and try the one on the right on your own. Number 5, finding the intercepts and rate of change given a graph of a linear function. Okay, so we're given a lot of information there with that graph. Charlie is draining an aquarium. The graph shows the amount of water in liters in the aquarium versus time in minutes. Okay, so A says, what is the amount of water in the aquarium at 0 minutes? Circle the correct answer. As time increases, the amount of water in the aquarium either increases or decreases. And then at what rate is the amount of water increasing or decreasing? All right. Well, let's label some things between points here. We want to find out what is the amount of water in the aquarium at 0 minutes. Well, I have time at the bottom here. I have time at the bottom. So I have starting at 0 minutes, 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, 6, 7, 8, 9, etc. And I want to find what amount of water in the aquarium at 0 minutes. Well, my 0 is right there at the left-hand side. So when my x is equal to 0, the question is, what is y then? Well, if I'm here on the x-axis, technically I'm at the origin, but I'm at 0. Where's my amount of water? It's way up here, and it's in liters. So my y is equal to 300 L, 300 liters. You can also write this as 0, 300, right? Because your x is always the first number, and then your y is the second number. So your x is 0, the y is 300. Circle the correct answer as time increases. So as time basically goes from 0 to 1, then 1 to 2, etc. Like time is increasing to the right. The amount of water in the aquarium. So as I'm going to the right, the water is ultimately decreasing. So as I'm going to the right here, so say I just right here, it's going down. So time is increasing from 3, now it's going down. At what rate is the amount of water increasing / decreasing? So it's asking us a rate, so it's asking us basically for the slope. So let's go per minute. That'll be easier, per minute. So where's the 1 go to? Right here. So I need to find the slope here. So the amount of water per minute, what is this? This is 1, 240. Again, my x is 1, and my y is 240. Says it there. And now I have 2 points. But the great thing about this is that I went down 60 liters. So I went down 60 liters, and then I went right 1. So my slope would be over 1. So I went down, meaning I decreasing. I'm saying that my change in y, hence y2 minus y1, 300 minus 240 minus 300 is negative 60. I decreased. So I went down 60 liters over 1. 60 liters over 1. Go ahead and try this one on the right-hand side, and if you have any questions, we can solve it within class. Number 6, finding the initial amount and rate of change given a table for a linear function. Okay, so at a factory, workers are draining, or I guess factory workers are draining a large vat containing water. The water is being drained at a constant rate, so that's kind of key, constant rate. The table below shows the amount of water in the vat after different amounts of time. So let's see what we're trying to figure out here. How much water was in the vat when the workers started draining it? Well, when they started draining it, the time just started, so it would start at 0. So we need to kind of go back in time almost. So how we're going to do this, notice here that it's at a constant rate, and that's key because from 15 minutes to 20 minutes is plus 5. And you'll see why this constant rate is important. Then 20 to 25 was plus 5, and then so on and so forth. And then from here, the more minutes we went, so every 5 minutes we drained 90 liters. We drained 90 liters, right? 500 to 410 is you're losing 90. And then 410 to 320, negative 90. This is important because if it's a constant rate, then we can technically work backwards. So we need to start at 0, and we know the rate is every 5. So 0, 5, 10, and then we hit 15, right? 15 is the time, so this is our x, this is our y. Well, 15, it says it's 590 liters of water. And I know that the rate is negative 90. So all I need to do then is I need to just add 90 to work backwards. Because we're trying to lose water over time, but I need to technically fill it back up to figure out what we started off with in the first place. So this would be 590 plus 90 is 680. So we added 90. And then 680 plus 90 is 770. So we added 90. And then 770 plus 90 is 860. So when the time started, the amount of water that was within it was 860 liters. And that's possible because the rate of drainage was constant the entire time. Now, in real life, that's not always going to be the case, but for this specific example, because it was constant, we were able to work backwards. Now, the question that was proposed is circle the correct answer. As time increases the amount of water, well, the longer the time is, it should obviously be decreasing because it's saying that we're even draining the water. And the question is, at what rate for C is the amount of water in the vat? So we're trying to figure out the rate here. Well, the change in Y we said was 90. And then the change in X was 5. 5 minutes. If we divide by 5, you get a simplified fraction of 18 over 1, which is 18 liters per minute. 18 liters per minute. So that would be our slope. Try the one on the right-hand side. And that will be the conclusion of lesson 1-3. Take care, everyone.